Good morning to everyone. I am Dr. Sumi MS. The topic of my today's presentation is Writing Test Benches in VERILOG HDL from Unit 5 ASIC Design and Testing. On completion, the students will be able to understand the purpose of writing test benches in VERILOG HDL and also be able to write down test bench code in VERILOG for various logic circuits. Test benches. Test benches are an essential part of digital hardware and software development, especially in the field of electronic design automation. They play a very crucial role in verifying and validating the functionality of digital circuits, integrated circuits, as well as other electronic systems. These test benches consist of stimulus block, output checker, as well as the design under test DUT. The non-synthesizable Verilog code of test bench generates inputs to the design and checks that the outputs obtained are correct. The stimulus block generates the inputs to the FPGA design and the output checker tests the outputs to ensure that they have the correct values. A test bench serves as a virtual environment in which designers can simulate the behavior of their design, apply test stimuli, and also observe the responses to ensure the correctness and functionality of the design before it is being physically implemented or manufactured. Purpose of test bench. The primary purpose of a test bench is to thoroughly test the functionality of a digital design or electronic system before its physical implementation is done. It allows the designers to catch and fix design errors and also functional bugs in a controlled simulated environment, reducing the risk of costly and time-consuming errors in the final product. Simulation environment. A test bench is created as a separate entity from the actual design that is being tested. It provides an environment that emulates the behavior of the design under test and contains the necessary stimuli to drive inputs and monitor the outputs. Simulation types. Test benches are used in various types of simulations such as functional simulation, timing simulation, as well as power analysis. Each type of simulation focuses on different aspects of the design and provides valuable insights for its behavior. Test stimuli. In a test bench, the test stimuli are applied to the inputs of the design under test to simulate the different scenarios and conditions. These stimuli can be predefined patterns, random data, or specific corner cases to test the design robustness. Output monitoring. The test bench also includes monitors that can observe and record the design under test output during the simulation. This allows the designers to compare the expected outputs with the actual outputs to check whether the content is correct or not. Debugging and analysis. Test benches facilitate debugging by providing detailed information about the design under test behavior during the simulation process. Designers can analyze the waveform results to pinpoint errors and also verify that the design meets the required specifications. Languages and tools. Test benches are typically written using hardware description languages like Verilog or VHDL. We also have certain higher level verification languages like System Verilog that provide more advanced features for test bench creation. EDA tools such as simulation tools, example we have ModelSim, and hardware description and verification languages as a whole make the process of this test bench creation more efficient and manageable. Coverage analysis. Test benches are instrumental in evaluating the functional coverage, code coverage, and other metrics to assess the effectiveness and completeness of the test. Regression testing. As designs evolve, test benches can be used for regression testing, ensuring that any new changes or optimizations do not introduce new errors or regressions in the design created. In general, test benches are an integral part of the hardware and software development process, thereby enabling the designers to validate and verify the digital designs through simulation process. They are crucial for achieving high quality, bug-free and robust designs, leading to reduced development time and cost while ensuring the functionality and reliability of the final product. This is an example for a NAND gate implementation whose test bench has been written for a Verilog code. So this is the Verilog design code for NAND gate with A and B as input and Y as output. And this following is the test bench code for the corresponding Verilog code. So we have given inputs A and B as 00, 01, 10 and 11. Similarly, we can write the test bench code for a Verilog design written for a half adder with A and B as input and sum and carry as output. And at the same time, we have the Verilog code for full adder with A, B, C and sum and carry, and the corresponding test bench code follows. So for different combinations of A, B and C in, we can get sum and carry as output. Quiz questions on writing test benches in Verilog HDL. Why do we need to write test benches in Verilog HDL? Write down test bench code in Verilog for a 2-input NAND gate. Thank you.